Welcome to part 3 of the MSP432 MCU training series. In this section, we will talk about the power system of the MSP432 P4XX. From a feature overview, the power system provides a wider range of power supply with true 1.8 volt operation, so you can use the device all the way from 1.62 volt to 3.7 volts. There are two internal core voltages to enable the system frequency power scaling. So for example, if you need to run your system from 1 to 24 MHz, you can use a 1.2 volt V core. When you need to boost the power performance to 24 to 48 MHz, you can use your 1.4 volt. To generate the internal core voltage, an internal voltage regulator can be used. Similar to many MSP430 devices, we provide a low dropout regulator. That is a default regulator that can be used to generate the voltage. However, in addition to the LDO, we will also provide a DC-DC regulator. This additional regulator is very efficient at high frequency and high load conditions. The supply voltage monitor and supervisor module has also been simplified significantly compared to the MSP430 family. It also adds low power performance modes for extremely low power consumption in LPM3, LPM4, and the .5 mode. The last thing to note, this might also be the most important feature, is that all the power transitions, configurations, and operations can all be done using the driver library APIs. As previously mentioned, MSP432 has a wide operating range, starting at 1.62 all the way to 3.7. The startup voltage requirement though is 1.65 volt, and at 1.71 volt, both flash accesses and supply voltage monitor can be enabled. The DC-DC regulator does require a minimum voltage of 2 volt for operation. The LDO can actually start operating all the way down to 1.62 volt. There are two internal voltage regulators in the system, the LDO and the DC-DC. So by default, the LDO is always the chosen regulator at startup. It is the most versatile one because it can operate all the way from 1.62 to 3.7 volt. The LDO can be used in all power, low power modes or active power modes. It is also very flexible and it's scalable to generate different output loads depending on the low power mode that is being used. The LDO also supports fast on and off switching operation. This can become quite handy when your application needs to jump in and out of active and low power modes frequently. On the other hand, the DC-DC is a secondary regulator. It also requires an external inductor, so there is an additional cost that needs to be considered into the system. It has a smaller operating range, starting at 2 volt all the way to 3.7 volts. The DC-DC is also only available in LPM0 as well as active modes. So what it lacks in terms of operating range, it makes up in its efficiency and is highly optimized for high speed and high load operations. DC-DC also requires a longer time to turn on and turn off from the LDO. In the event that VCC drops below 2 volts, the DC-DC will automatically turn on the fail-safe switching mode and turn back to LDO. Once the VCC rises above 2.0 volts again, it will switch back to DC-DC automatically. Let's take a quick look at the MSP432 flexible operating power modes. MSP432 family introduces the similar power modes that you might have seen on MSP430, including active, LPM0, 3, 4, 3.5, and 4.5. However, two new modes have been introduced. So first off, let's start with active mode. In active mode, you can use either V-core voltage for low power and medium performance. When the system needs to run anywhere between 0 and 24 MHz, you can use the V-core level 0. At this point, either regulator can be used, either LDO or DC-DC. For high performance at higher frequency, such as from 24 to 48 MHz, it's highly recommended that you use a DC-DC at this point. When you use the LDO, the current consumption is around 166 microamps per megahertz, but when you use the DC-DC, the current consumption in active mode is around 100 microamps per megahertz. Two new modes have been introduced into MSP432, and those are the low frequency mode. The low frequency mode is a special mode that keeps everything in the system active. That could include a CPU. However, all clocks must be less or equal than 128 kilohertz. This allows the entire system consume around 70 microamps or less. The LPM0 mode is very similar on MSP432 to MSP430. In this mode, all peripherals and clocks are active except for CPU and the main clock or M clock. In this mode, the consumption is anywhere from 65 to 100 microamps per megahertz depending on the regulator that you use. Next, LPM3 and LPM4 are also low power modes that you might have seen on MSP430 before. In this mode, everything in the system must be operating at at most 32 kHz. There is no CPU running. However, SRAM is retained, and you do have RTC, watchdog, and GPIO active. Those are the possible wake-up sources that can interrupt and return the device to active mode. In LPM3, MSP432 can consume around 850 nanoamps. Last but not least, LPM 3.5 and 4.5 are again similar modes that are borrowed from MSP430. In these modes, the entire system is powered down. In LPM 3.5, the one SRAM bank can actually be retained. However, the core logic and everything else is powered down. You do have the RTC that can still be running to keep track of time. In LPM 3.5, you can use the RTC interrupt or interrupt through a port pin to wake up the device. In LPM 3.5, you can use a reset or a GPIO to return the device to the active state. A few things to remember: the MSP432 blends really well between MSP and the Cortex-M architectures, and it uses the same sleep and interrupt mechanisms to wake up and go to sleep. There are a number of ways that you can use to instruct the device to go to sleep or wake up. You can either use Cortex-M CMSIS instructions, such as __WF5. You can also use MSP430 intrinsic conventions, such as go to LPM0 or go to LPM3. In addition to the intrinsics, we also provide a set of driver library calls that will allow you to transition between states extremely easily. One last thing to remember from this power section, and hopefully this is the most important thing you remember, is that there is one powerful driverless API call named PCM_set_power_state, and this single API can allow you to transition between all available power states on the device. You can use it to change your power modes, changing vCore, as well as changing the regulator from DC-DC to LDO and vice versa. So this concludes part 3 of the MSP432 training series. Thanks for watching.